Welcome to the class of Microwave Radar Engineering. The subject code is KEC074 and this one is the lecture number 21. In the last lecture, we have discussed about the measurement of insertion loss, attenuation, and in the today's lecture, we will discuss about the measurement of impedance. First one is the today we will discuss about the measurement of impedance, and the first one there are 2 or 3 methods for measuring the impedance in a microwave bench, and you know that impedance can be inductive, capacitive and resistive. Means impedance in a waveguide can be due to some discontinuity inside a waveguide or at the terminating of waveguide. It could be capacitance or capacitive, inductive or resistive or their combination. Now we have already discussed about the what are the applications of magic tape. In the applications of magic tape, one first topic was that we can measure the impedance using a magic tape. So apart from magic tape, we have 2 different methods for measuring the impedance. First one is the using a slotted line and another one is the reflectometer. Now we will discuss the 3 methods to calculate to measure the impedance. First one is the impedance measurement using a slotted line. Now in this method, impedance is measured using a slotted line and load, that is ZL, is there, and by using the slotted line section, we will measure the Vmax and Vminimum, and from Vmax and Vminimum we will calculate the ZL. We will calculate the Vminimum through ZL and Vminimum by short circuiting the load, or you can say by using the movable short. First step is for measuring the or calculating the load impedance. First one, we will calculate what? VSWR. As we know that VSWR equal to what? Vmax by Vminimum, or you can say that the reflection coefficient equal to S minus 1 upon S plus 1 when with load ZL. Now first on moving the slotted section, we will detect the positions of 2 successive minima. So while moving the slotted section, we will find the distance d between the 2 successive minima when there is a load, that is ZL, and from there we will find the lambda g, that is guided wavelength, that will be equal to lambda g equal to 2d and beta equals to 2 by lambda g. Clear? Now next we will measure the position of first minima. Now we will measure the position of first minima starting from the load side towards the generator. Means we will see the first minima. Means if I say we have distance between the 2 minima is d, and now we will find out the position of first minima starting from load side towards the generator. Now we will move the slotted section towards the generator side and note the position, that is x1. Now then when it is replaced by, now we will replace the movable short. Means now we will place the ZL with the movable short, and at that time we will calculate the another minima, that is known as the x2. Clear? Now see, phi will be equal to 2 into beta into x1 minus x2 minus pi. This reflection coefficient with phasor reflection coefficient into e to j into phi, and ZL equal to will be what? Z0. ZL equal to Z0 1 plus reflection coefficient minus 1 minus reflection coefficient. From this we will calculate what? Measure the impedance or ZL, because reflection coefficient can be calculated from this here and phi is calculated from this side, and reflection coefficient is calculated from this side. From here we will calculate the what? Reflection coefficient. And for calculating the reflection coefficient, we should know the VSWR, and VSWR we will measure in the first step, that is VSWR equal to Vmax by V minimum. Clear? Now see, if the shift is to the left, means if I say in the first step we have discussed that we will discuss the we will calculate the first position x1. Now see, if this shift for second step, if this shift is towards the left, then I can say that it is inductive, and if this shift is towards the right side, means the minima is towards the right side, that is, then I can say that it is a capacitive load. So this one is the setup for the step 1. In this we will use the unknown impedance ZL, and from unknown impedance, when I have connected the unknown impedance, slotted line move in such a way that we will calculate the VSWR from the power from this. We will not use the power meter, we will use the VSWR to calculate the VSWR. Second step is we will replace what? We will replace the unknown impedance to the shorted termination. From here, power meter is not connected, VSWR meter will be connected, and from the slotted section we will calculate the position of minima, that is x2. Clear? Now next one is the next step is the next method to calculate the measurement of impedance is using the reflectometer. Reflectometer is a device from where we will calculate the reflection coefficient, and this reflection coefficient is equal to what? Is equal to under root of reflected power upon my incident power, or you can say reflected voltage upon my incident voltage. Clear? Now we will see this one. From the bench setup you will see that micro source is there, then there is isolator will be there in between, and then attenuator, then forward direction coupler, and this one is the reverse direction coupler, and the unknown impedance is connected here. Forward direction coupler, from here we will determine what? Incident power which is going towards this side, and the reverse detector means reverse direction coupler, from here I will calculate what? Reflected power. And this incident power is can be measured through a power meter, and reflected power can be measured through also power meter. Or you can say that from these two devices, instead of these two devices, we will connect the reflectometer. Clear? And from there we will calculate power meter. PI can be calculated and PR can be calculated. Ultimately we can calculate the reflection coefficient. When we have calculated the reflection coefficient, means this reflection coefficient, as we know that in the first unit we have studied that this reflection coefficient is equal to what? ZL minus by Z0 upon by ZL plus Z0. So and therefore ZL will be equal to what? Z0 upon by S, and this S is equal to what? VSWR, or 1 plus my reflection coefficient, 1 minus my reflection coefficient. Clear? So this circuit setups in figure 2, where two direction coupler are used to sample the incident power PI and the reflected power PR from the load. both direction couplers are identical except their direction. So reflectometer directly reads the voltage reflection coefficient from the display of accurate value. Clear? And when we have calculated the reflection coefficient from the reflectometer, or if I calculate the PR and PI from power meter, then also we can calculate the reflection meter reflection coefficient, and from the reflection coefficient using this formula we can calculate the unknown impedance. Clear? Now see this one, same concept is there. VSWR equal to 1 plus reflection coefficient, ZL minus में Z0 upon में Z plus में ZC. Clear? And this ZC is equal to what? Generator impedance, or Z0 is what? Is a known wave impedance. Now next method to calculate the measurement, to calculate the unknown impedance using a magic T and the null detector method. Now see, as we know that this one is the setup for calculating the unknown impedance. Now see, as we know that the magic T is a 4-terminal device, and magic T has a 4 port device. First port is this one. 1 and 2 are the collinear ports. 3 and 4 are the 3-port. Third port is the E arm plane, E arm, and H is the fourth port is your H arm. This is a short description of this one. Now if I insert the power from, if this is act as a input port, then the output from port number 1 and port number 2 will be equally divided between the two parts, between the 1 and 2, means both the power will be equally divided if ideally. Similarly, if I give the input from port number 3, then both power received at the port number 1 and port number 2 will be of equal but out of phase. Now see this one. If I say this is a magic T, and this magic T, port number 1 is connected with the known impedance and port number 2 is connected with the unknown impedance, and where port number 3 is connected to a source and port number 4 is connected to a variable attenuator, then null detector. Port number 4 is what? E plane. Now see, if I make fourth port as the input, means fourth port is as an input, then this will give what? This will, the power from this port number 4 should be equally divided between the two ports, port number 1 and port number 2, and no output would be obtained at port number 3. This is the ideal property of the magic T. But as both ports are of unequal impedance, means Z1 is, if I say Z1 is not equal to Z2, means then some part of the power will also get at the port number 3. But now if I say that if I connect this null detector there, means some power is, if I say some power is saving at this, it means I can say that Z1 is not equal to Z2. Now, but if I vary this variable attenuator or vary the impedance of this one, or then null detector should be adjusted in such a way that output at port number 4 becomes equal to 0, and when output at port number 4 becomes equal to 0 only when Z1 is equal to Z2, means when known impedance will become equal to unknown impedance. Clear? So how much power is reflected back by Z1 or how much power is reflected by Z2 will be given by reflection coefficient, will be given by reflection coefficient 1, and this one is reflection coefficient 2. So some power will get merged at this remaining power or some power which is reflected back by Z2 or Z1 will reaches to port number 4. When the input output at the port number 4 becomes equal to 0, then at that time I can see that Z1 is equal to Z2. Clear? Now see this one. A magic trick can be used to measure the pure resistive load, the unknown impedance Z2 and variable unknown load is Z1 on the collinear port 1 and 2, microwave sources at port number 3 of H plane, and null detector with the at port number 4. The power source at port number 3 giving voltage level of A3. If input power is A3, which gets divided into port number 1 and port number 2 as A3 by root 2 and A3 by root 2. This is the property of what? Magic T. The load at these two ports, port number 1 and 2, may not be equal due to what? Due to Z0 is not equal to Z2. Due to the characteristic with Z0 and therefore have some reflection coefficient. So we will now vary what? Z1. We will now vary the Z1 until the null detector shows 0. When null detector shows 0, then I can say that Z1 becomes equal to Z2 and Z1 is known impedance. We can calculate the Z2. So therefore, accurate value of Z2 can be known directly. Clear? So these are the three methods to calculate the measurement of unknown impedance. The book I have referred for preparing the slides is Microwave Radar and RF Engineering by Prakash Kumar Chaturvedi, Springer. Thank you.